Greetings, math friends. As a resource tonight, I'm going to be using this college algebra textbook. We are going to look at taking a matrix and finding the matrix of cofactors for a given matrix. Before we start into that, I'm going to create another matrix that we are going to use as a reference. When you do cofactors, there is a positive or a negative one that multiplies across one of the terms that you get, and we can create a reference matrix to help us determine whether that should be positive or negative. Looking at the size of matrix that you have, in this case is 3 by 3, we're going to create another 3 by 3 matrix for our reference. On the main diagonal will be positive ones. It's always positive on the main diagonal, which is moving from left to right, from the upper corner to the lower corner. And then as we go across the rows, it's going to alternate. Since we start with positive, it will be negative, and then positive again. When we start at this row, starting with the empty one, it's going to have to be negative since the next one is positive. And then we end with negative again since we had a positive here. Here we're going to start with a positive because we're going to switch to negative and then back to positive. So we're going to use this as a reference to know when we create our cofactors, which ones are going to be multiplied by a positive one and which are going to be multiplied by a negative one. From the textbook, we have this equation. The cofactor is going to be based on the negative to the I plus j power, and I plus j is this address from the cofactor, and that's locating the element that we're using inside the original matrix. It goes by row first and then column. So this is the 1, 1 position. So the I and the j would be 1, 1 here. We would add 1 plus 1 to get 2. Negative 1 squared would be a positive 1. We see in the first position we do have the positive 1 there. This m represents the minor with respect to the element. So in the first position, we would eliminate this top row, we would eliminate this first column, and the minor would be the 2 by 2 matrix 5, 6, 8, 0. So that's what this pattern tells us. Since we've already created our reference matrix here, we're going to ignore this first term to begin with. We're going to find all of our minors based on the element in the original matrix. And then as we plug them into our matrix of cofactors, we will multiply by the appropriate negative when we get to that point. We're going to start out looking at the minor for position 1, 1 here. If we take out the top row and the first column, we see that we have 5, 6, 8, 0. That's the 2 by 2 matrix here. And now we're going to take the determinant of that matrix. And if you don't remember how to take a determinant of a 2 by 2 matrix, we are going to multiply on the main diagonal and then subtract, multiplying along the other diagonal going the other direction. Since we're multiplying by 0 here, this term is going to go to 0. This is going to leave us with a negative term, since this is going to be whatever this term is being subtracted. Since they're both positive, that means we have a negative term. 6 times 8 is 48, so my minor for position 1, 1 gives me negative 48. Now it goes in this position, so when we create our matrix of cofactors, it's multiplied by a positive 1, and that will be the actual cofactor. I'm going to go ahead and start building my cofactor matrix over here. And now we're going to move on to the next one. If I want to look at minor 1, 2, I am going to be in the first row and in the second column. So we are going to eliminate this column and this row. So looking at the minor matrix, we get -2, 6, 11, and 0. Again, we're going to multiply on the main diagonal and subtract the opposite diagonal. We get -66 here for the determinant. 6 times 11 is 66, and we're subtracting that from 0. This is going to go into this position. We see from our reference that this should be multiplied by a -1. So this is going to come out to be a positive 66 in the 1, 2 position. Moving on to position 1, 3, we are going to eliminate this row and this column. We need the determinant of this matrix. -2 times 8 is -16. Subtract 5 times 11, which is 55. This is going to give us an overall negative difference. We're multiplying by a +1 to this number, giving us the cofactor of -71. And then we're going to continue to row 2. We are now in row 2 here, so this will be eliminated here. We will eliminate the first column, and that will give us 0, 3, 8, 0. When we find the determinant of this minor, we find that it's -24. We are going to multiply by -1. Our cofactor will be a +24. Eliminating second row, second column, we have 1, 3, 11, 0. And the determinant of the minor is going to be -33. We multiply by a +1, so this will be -33. Eliminating the second row and the third column, we are left with 1, 0, 11, 8. We get the determinant of 8, and we multiply by a -1 to have a cofactor of -8. Now we're going to move on to the third row. Eliminating the third row, first column, we have 0, 3, 5, 6 as our minor, and we need to find the determinant of that. We find the determinant is -15, and we will multiply it by the +1 here to have a cofactor of -15. And then we move to 3, 2. Eliminating row 3, second column, we have 1, 3, -2, 6. We end up with a +12 here. We'll multiply it by a -1 here to have -12 as our cofactor. And then lastly, we will eliminate the third row, the third column, to have 1, 0, -2, 5. We end up with a determinant of 5. Multiply it by 1, we will have 5 here. So given a matrix, say J, if we find the matrix of cofactors, we will have this 3x3 matrix with these entries. Hopefully this has helped you understand how to find a matrix of cofactors. This is useful. It's a step toward finding other information about matrices. Cheerful calculations.